And now.
I'll bring Prasad up here with his, spectacular grandfather.
Right of that, yeah. All right, we're live now.
Yeah. It's not our house. It's not our house. Oh, no.
Screen sharing is on. Thing here. Mike is here.
Can you hear me? Hello, everybody. It's game time.
Gonna earn your keep tonight.
So Jan couldn't make it tonight, so I'm filling in. My name is Tom Delasco. I'm the vice president. And welcome to the. Thank you. This is the November meeting. So let's get rolling. Okay. Right after our last meeting, a couple nights later, the late Sunday night, actually only Monday morning, the last task of the Titan's shadow crossing Saturn occurred. And on the left bottom, the deer recorded, and it's right there, a little niche. And you can watch up here and you'll see the shadow appear in Tom's shot. There it is there. I mean, it's right on the cusp. It's right there. And this is a great idea. I love animation, so that's I really love that. But that was something that happens. Oh, the next cycle doesn't start until 2038. So when the rings get narrow again, but show's over for now. But speaking of Saturn's rings got edge on back in March. Now we couldn't see it because it was close to the sun at that time. However, we get a real near miss here at the end of November, and November 23rd is the narrowest. It's 0.37 degree tilt. With that, there's a little finer detail here, but right now we're sitting right about November, right about here. So we're really getting narrow in that window. From now till about the first week of December is the time you want to take a scope out and see what you can see with the rings. It's a little quick animation there from August through the 27th. You can see the rings, how they're getting narrower there, but they're going to be half at the narrowest point there. They'll be half that at the 23rd of November. So
They
keep an eye
actually
on that.
disappear at some point?
They won't, we're not going to go edge on this. In March, they were edge on. This time, they're not going to be edge on, not like zero, where they would go away completely. They're going to be, but they'll be really thin, and it might be kind of a little tricky to see almost. Maybe a little, so it's kind of keep an eye on, just see how it looks around that time frame, around the week. Either way, the 23rd, it's all about the same. But and we've had a comet that some of you have seen. A lot of you have photographed it, imaged it. And so I'm just gonna have a quick gallery kind of thing of some of the shots from some of our members. And there's a wide variety of members got the image this. Now I only looked for it twice, I think, in binoculars. And both times it was early in October, so it was pretty close to sunset. I could see the comet, but I really couldn't see the tail. So it was kind of, disappointing there. Comet Swan was at the same time, but that was just a little ball, a little fuzzball, and dimmer. But these are two really spectacular shots by Dan and Joe. And these are both taken. Dan was out west when he took that, and this is a remote telescope image that Joe has Joe has a remote telescope set up down in Texas, and he got that image, which is just beautiful images. Okay, now, oh yeah, one more thing here. This is Swan. I only have one image of Swan here, and I did it because of the position. This is the Swan M17, and this is the Eagle Nebula M16, and the comet kind of split the uprights there. So it was kind of a neat opportunity that one night to capture that, and Dan happened to catch it. It was kind of, it wasn't as good here, but he was down by the shore. He had a clear night, so he got it. Okay, now, big news for me is the sun right now. This is back October 11th to the 15th. This is really kind of wild. This starts out, watch it, starts as nothing practically, and in 5 days becomes this massive situation here. Now, this is the magnetic fields of these things, where the red represents the magnetic fields of the sun going out, and the blue represents going back where it goes back into the sun. But usually, in this cycle, if you're in the northern hemisphere of the sun, at this cycle, the red there will be first, followed by a blue spot in a really simple case, just like if you had two spots in the simple case, it'd be red blue. Well, this thing really goes nuts, and it just gets all this tangled mess in here. And why that's important is because the magnetic field lines, the sun's a gas, right? So it rotates different speeds at different latitudes. So they're not quite rotating together. So they're beginning to get further apart, stretches magnetic fields, and they twist and they pop because of the torque. When they do that, they release tons of energy. And here's this is the 21st here. This is 21st, massive. Now it just made the corner over there. If that had still been pointing towards the Earth, we would have had a spectacular aurora, probably better than last year's October 11th aurora, which was really good. But then again, this thing's so active that it popped again on the 29th and the 30th, and it's rotating around. You see what's going this way. Now it's kind of going here. Now it's going more this way. And then this is it's called AR40, is active region 4246, and it's back as also known as AR4274. Whenever a spot comes around, it always gets a new designation. They don't keep the old designation. So this was on the 4th. That was a white light view. Now the seeing on these nights, this day, is absolutely atrocious. For those of you who are familiar with the seeing, it's just a steadiness of the air, where they goes excellent, above average, average, below average, poor, and then they have white, and they call that cloudy. I say it's cloudy because you have to be an idiot to go out if it's white, because the sky is so turbulent that it might as well be cloudy, basically. I think that's probably how you do it. But because this was rotating around, it was white, it was cloudy, they said, so I managed to get these, but it was really tough because the atmosphere was just boiling. It was hard to even see the spots. So I got real lucky here, really lucky. There was an X18 flare on the 4th. I was out with the scope just to get one image. It was the goal. I take a picture of that white light image you saw. I took it. I changed scopes. I put it over. I go to take a picture. It's sun is in the trees. I have to wait about 45 minutes till it clears the trees to this little opening for another 45 minutes. And it's a good thing it did, because I would have taken that picture, packed up and going in, but I had to wait. I came back out. Within a few minutes, this thing just erupted. And you can see in the beginning, there's the white is the flare itself. And what caught my attention, you always have like these, a lot of times with these active spots, you have these little active regions. But when I saw this go, I go, whoa, that's pretty unusual, middle of nowhere, getting a flare activity there. This might develop into something. It was a lot more than I expected. You see this whole thing just blow off. And this, by the time it just started here, till the time it was out on the screen, it was only about 17 minutes. This is fast. This stuff's happening quick. I could see the difference in every single frame. I was shooting 30 seconds, little videos. And between the frames, you could just visibly see the prominence that shifted position, obviously. It was really an amazing thing. So, since then, besides it's going off the 5th, going off the 6th again, it's still going. And so you want to keep an eye out for auroras. When this thing comes around, if you go to like spaceweather.com, there's always a little section on top. If there's a possibility for an aurora, it usually has a mention here. They'll say northern states or the mid-latitude states, something like that. But it says mid-latitude, we got a chance. And they give these things ratings, G1 to G5 type of thing. G1 and G2, we're not going to really see around here. They won't come down far enough. G3, maybe, but G4 and 5, we can start to see them this far south. But anyway, look today though, and you saw that slide a few minutes ago where you had the red and the blue showing that. Well, now there's usually one on the leading edge and one on the back. Well, now those spots are lined up above one another. There is no leading. There's a pair of reds and pair of blues, and that is really unusual because now they're really going to twist and shred because now they're going. It's purely 90 degrees from their fields because they're rotating at different speeds, and the fields are going this way and they're rotating this way. So it's just they're going to be tearing. So there's going to be. If you have a solar scope, keep an eye out on this, but also keep an eye on the aurora possibility. Anyway, that's my spiel in the sun. It's a good time to see it. For the next about 8 days, it'll be crossing. And it's pretty unusual to get that. Yeah.
Could you spend a minute talking about the KP index? Because I know a little bit about it. I know that auroras are going to be more likely if it's up around 8 or 9, but
I know
the index is.
the amount you just said is probably more than I knew about the KP index. I mean, I heard of it. I just go by, there's a rating, they give it this G number, 1 to 5. I just look at that. Because I know historically, if it's a 4 or 5, I probably can see it from here. If it's a 3, maybe not.
Case of P of 5 is like possibility of a storm, and
Okay.
it goes up to 9.
How long does it take those mass ejections to affect our ions?
Usually a few days, two or 3 days, they'll be coming in. And they have been coming in. They've been getting auroras up north, but not, not this far south yet. Anyway, congratulations, Elliot Purdy, Frank Palacimo, and Gary Chapizano, who made this the December issue of Sky and Telescope, International Astronomy Magazine. Let's hear it for those guys, huh? I wrote an article on the IC objects, which are, when you're first starting out, usually if kind of the rite of passage is you try to find all the Messier objects, they're deep sky objects, 110 of them, and you try to find them. And then maybe you move on to the new general catalog, the NGC numbers. And if you really get like Al, who's really seen everything, you get to the IC numbers, which are even fainter things. Each level gets harder. And but he has a great article there on how to find the objects and some really nice photography with Frank and Gary supplies. I just wanted to mention that. Okay, here's the candidates. Looks like I'll be running. And Scott will be moving from, because we all had, all the people on the board, we turned out 3 years. We all had to either go somewhere else or just not be on the board. So I'm running for president. Scott's moved from treasurer to VP. Kathy has graciously agreed to be treasurer, and Brett likewise is secretary. And on the let's do it for those guys. And 2 of the 3 members at large, Andrea and John, were there last year. They're only in the 2nd term, so they can be this year and next year if they wanted. And Joe has joined in this year, so he'll be joining us. And the junior member gets appointed by the board in the June timeframe. Right now, it's Daniel. Anyway, so real quick here, voting. Now it looks like it's a why bother voting, but there's a number of bylaw changes that are in the election thing. So please vote and put it in, and you can do write-ins too. You know, if you want to put your name in, you can put your name in, and but there's bylaw changes. So if you, at all possible, try to vote. It opens up on the 15th. Last start part of the year is on the 29th. Dress warm. It's probably going to be chilly. We have our next Zoom the Wednesday before the December meeting. It's the 3rd. Next month's meeting is on the 5th. Following day is the business meeting. Everybody is invited, not just the board meeting. It's all members meeting. We meet here and we go over what the club did and what we can do better and ideas. Everybody has a new idea. Let's try this. Let's try that. Let's do something different. That's a good time to bring it up. We're going to have 2 clinics in January, 2 indoors, 17th and 31st. The topic of these will be announced next meeting in December. We've got some basic information, but we have to kind of work out the details. And then you got your January. Whoop, sorry. Oh man, that's okay. And that's the January meeting. Okay. Welcome. Oh, before I forget, so, Stan Williams has brought in astronomy magazines and sky and telescope magazines on the back table there. And they're free for anybody to pick up as many or one or as many as you want of those magazines. I just wanted to mention that. Because Brian told me to mention it, and when I saw him, he reminded me.
My name is Brian Lee. I'm the welcoming chair. We have 4 new members this month. Jennifer Beadler, I know she's here tonight. Just stand up. Kelly Ford, Kip Woolen, and Stephen Cosmo. So welcome.
Okay. Joe, is there oh, there you go. Anything with the rentals or
We have several telescopes available, and, come see me or contact me.
okay, so basically we have a few scopes available. If you want to rent a scope before you buy something or try a smart scope that maybe you were thinking about, go see Joe after the meeting and or send him drop an email and you'll be good. Astrophotography. Now I'm going to have Gary come up. He's going to talk a little bit about the astrophotography group. Thank you. Do you want this or you want?
This is the backwards folder.
Yeah.
This is the one.
Yeah. And which one is your chair?
It's always the opposite of what you think.
Yeah, opposite of what we think.
It's from China, so they're right there.
Hi, I'm Gary Trapezzano, and I'm the astrophotography chair for the club. I just wanted to spend a few minutes talking about some up.
Is your mic on?
I don't know. Now it is. Hello? No?
Is it switched all the way up?
Hello?
Yeah.
Standby and on are different things.
On and
I'm
very on.
Gary Trapezzano. I'm the astrophotography chair for the club, and I wanted to spend a few minutes just going over some upcoming things and also just talk a little bit about the resources that are available to the club by recording some of the astrophotography meetings that we hold every month on Zoom. So the meetings start at 7 o'clock for a beginner Q&A session. So if anyone is thinking of getting into this area or has gotten into it and has some questions, that's a great time to come for beginners kind of question and answer. We then welcome any new attendees, and then we either have a feature presentation or show and tell, and you'll see in a few minutes how the meeting sort of how that varies. And then at the end, if there's any remaining time, it goes back to questions and answers. And question and answers are encouraged throughout the whole meeting. And a lot of times they occur naturally, even during show and tell. If someone's showing a picture, someone will say, hey, how did you do that? Or what are you doing there? Sometimes it's showing a picture and saying, I have this artifact in my picture. I'm not sure where this is coming from. Has anyone seen that? Has anyone experienced that? And then we put it to the open question, and then people try to figure it out and help out. The next meeting will be on December 5th. This is going to be and what we consider sort of an ad hoc meeting where it's a show and tell, so that we have more time to look at people's images, discuss things that come up, things like that. And the reason why I'm pointing that out is as more of a show and tell meeting for that, you'll see very soon how previous meetings, we've had a lot of very interesting presentations in addition to the show and tell. But every once in a while, we do a pure show and tell just because it can sometimes get a little rushed when people are trying to show images, and we've had a feature presentation and things like that. So
December 3rd. December 3rd?
December 3rd.
Wednesday?
oh, I'm sorry. Sorry about that. It's the date up top. See the one on the calendar? Sorry about that. It's all that pressure, Tom, of getting you the slide. So anyway, I just want to point out this resource. All of these meetings are recorded, just like this meeting is recorded. All of them are recorded and they're put on the DVAA website, their YouTube channel, I should say. And if you look at some of the past meetings, if I go back to the July meeting, Tom Strovanak gave an excellent feature presentation on a mount that he put together and basically upgraded for remote control so that he could do planetary imaging from inside his house. This is on YouTube, so if anyone is interested in doing something like that, you can get to that resource as available from the club. I also, on that same evening, did a presentation on how to do the star trail kind of Milky Way images. So these are all available on the website if anyone has any interest. I talk about workflow in that, and also the actual processing steps, and basically go through it step by step. The August meeting was one of the ad hoc meetings where we did mostly show and tell and then questions and answers. And you can see we have a pretty good sized group of people that regularly attend this meeting. In the September timeframe, we had a presentation that I did as the feature presentation on data acquisition and processing of the small globular cluster M71. And I know a number of people in the email group, they'll be taking pictures with sea stars or things like that, more like EAA, and they're saying, I'd really like to take the next step and try to learn how to process these. Like, what do you mean by stretching? And what are all these different tools? This resource on YouTube that's sitting there, you can watch it at your leisure, goes through step by step how to do that. And there are other ones that we've done in previous meetings that I'm not highlighting here. These are just the recent ones that also go into some of those same details. When I did this presentation, I talked about the workflow. What is linear processing? What is nonlinear processing? What are the steps involved in doing something like that? And I picked a globular cluster because it's a fairly simple target to process. It's not like you're necessarily taking the stars out of it and trying to pull up faint nebulosity, things of that sort. You can process it all as one object, and it's fairly simple, fairly straightforward type example of doing this. That's on the website. This is also from that same meeting. This is talking about stretching. And what became apparent when I was doing this talk is that there was a lot of confusion about what is really a histogram. What is really curves? When people say they use curves to stretch, what does that mean? So I actually put together a presentation for the October meeting that went into histograms and curves. And this was a fairly deep dive into it, going back to some of the theory of it. Why do you use this, and things like that. These resources are on the DVAA YouTube channel. Look at them whenever you want, take however much time you need, go back to it if you get busy and you couldn't finish it, or watch it again. So these are club resources. These are just a couple screenshots from that presentation. The meeting that we just had this past Wednesday, that is the 5th. That's where that 5 came from when I copied this slide. The meeting that I had on the 5th was an excellent presentation by Prasad Agrahar. He was back here just at the beginning of the meeting with his spectroheliograph system that he put together. He gave an excellent presentation on what got him started with that, going back to some of the early history of that. You can see we had, I think this is probably close to record, if not record attendance. There's 20 people shown there, and I think there were 5 more that had scrolled off the screen. So we had a lot of people there, a very, very excellent presentation. If anyone's interested in doing solar imaging, things like that, I highly recommend you watch this. He went from the early history of spectroheliographs from the early hail instrument at the turn of the 20th century, so in 1900, and also talked about his actual sort of building it and then learning from that, and then even processing the images. Our December meeting, as I mentioned at the beginning, will be a show and tell meeting so that we get back to some of the images people have been doing. There have been a lot of them recently, and unfortunately, we didn't have time this past Wednesday to do any of those. So anyone who has images that they wanted to show 2 days ago, keep them for the December meeting, because in addition to new ones, we'd love to see what people have been working on. And then in January, our very own Joe Lamb, I know he's back there hiding. Hi, Joe. Is going to talk about lunar imaging and lunar imaging processing. Joe has done excellent. I don't know if it's. Yeah, it did drop out. Hello?
The battery, maybe?
I don't know. But anyway, this is the last slide anyway. So I'll just talk louder. So Joe is going to be doing a talk on lunar imaging and processing. It's done. I'll just leave it. So join us in January 28th. So we actually kind of skipped the beginning meeting because of the holidays, things like that, right? So the next date will be January 28th. And thank you.
Testing. So. Bring my slide back. I have one slide, but. Oh, you want yours back? Let's bring the slide. Oh, no, I just want you to go. Two slides. Yeah. Okay. That's dead. I need a new battery. Oh, sorry about that. This is just a gentle reminder. It's just time to start thinking about renewing membership. Next month, you'll probably see a slide saying it's time to get serious about renewing your membership. But this is just real quick, it's coming up again. And now we have an observation report from Joe Lamb, who's our past president and current Reynolds chairperson, on Andromeda's family, a brief look at M31's brightest satellite galaxies. Yeah, take it away, Joe. Software. Oops, chicken. Okay, right. No pressure.
Hi, everyone. Just a few minutes talking about a little bit about our galactic neighborhood.
Let's get you at the blue. Come up, chips.
It is.
Is
it not up for some reason?
This might be short. So I'm sure that most of you are familiar with these two satellite galaxies, and named after Magellan and his ill-fated trip to around the world. But the Milky Way has about 61 possible or proven satellite galaxies. It's really quite a menagerie. But Andromeda has a pretty large family too, and a varied family, and a tremendous mixture of bright and dim, et cetera. And I thought maybe tonight we could take a look at maybe some of the brighter ones, and discuss them. And this chart, don't be scared by it. There are only three things that I thought we could really talk about. One of them is, if you look at the distance for these objects, they're all between 2 and 3 million light years. And if you look at the discovery of them, if the discovery dates pretty much follow the brightness were discovered first, and then after that, gradually the dimmer ones. And the discoverers are kind of like a who's who of classical astronomy. I mean, there are some big names in there. So I thought maybe we'd take a quick gander at them. This is a drawing, a beautiful drawing done by a fellow by the name of Michael Vlasic. And it was done from a dark sky site. And I wanted to point out how bright the center of this galaxy is, but also how bright the two satellite galaxies are, M32 and NGC 205. They are 8th magnitude, and they are about as bright as like M104 or M64. They're brighter than M65 and M66. And if somehow M31 was snuffed out, these objects, I would guess, would be marquee objects, that people looked for. So they're really quite stunning. M32 is rather small, magnitude 8.1, mostly old faint red and yellow stars with no dust or gas and no star formation. And this particular galaxy gets more and more dense as you go from out to in. So it's rather small, but it's really very, very bright. And the idea is, and I think Dr. Conrad spoke about that last month, the idea is that it's a galactic nucleus that's been stripped of everything else. And it's just kind of floating around in there. And it kind of points to the turbulent history of the Andromeda galaxy. NGC 205, on the other hand, is really quite different. It's 3 times bigger, it's dimmer, and it's listed as an elliptical, but it's kind of unusual because it has a lot of young blue stars, and it has a lot of dust and gas near its center. And it also has 8 globular clusters, which is kind of unusual. And one of them, this little guy right here, is 15th magnitude and probably within range of a 16 or 18-inch scope visually. This photo is just taken with a small refractor. The HST shows this dust and gas near the center, but a small telescope may be able to see it as well. So kind of within, that dust and gas is within range of a small scope. The next objects, NGC 185 and 1GC 147, are about 8 degrees north and across the Cassiopeia border. And they're interesting as well. These are 9th magnitude objects, about 1 degree apart. NGC 185 was discovered in 1787 by William Herschel. It's a dwarf spheroidal, and it's unusual because it has an active galactic nucleus, and usually that, they're the purview of spiral galaxies. It's unusual to see this on an elliptical galaxy, and in particular, they think that it's a Seyfert 2, and it also has young stellar clusters, and it has a lot of dust and gas. NGC 147 was discovered 42 years later by William Herschel's son, John, who was also an amazing observer. Dwarf spheroidal, it's farther away. It's about 500,000 light years further away. It's fainter, it's larger, and more difficult visually, and contains many older stars. Just a shot, just drawings by Jeremy Perez, who's a Flagstaff, Arizona amateur. He used to run the astronomy sketch of the day years ago. You might have seen that, but a great sketcher at the eyepiece. And for the next object, though, I wanted to congratulate Al and Gary and Frank for the beautiful article that they wrote and for the great photography. And the next object is I was going to talk about is IC10. And Gary, I think, Gary, you shot that? Yeah, what a great shot. What a great image. For this particular object, we go even further north, another 10 degrees, into the W of Cassiopeia. And this particular object is right in the middle of the Milky Way, just 3 degrees from the galactic plane, and about 1.5 degrees from Beta Cassiopeia. So if you have a smart scope, great. But if you don't have a smart scope, you can set the scope up right on CAF. Boil 3 4-minute eggs. And at the end of that, you'll be low power view. You'll be right on that particular galaxy. So just a shot of it in a small refractor. And you can see, being at the middle of the Milky Way, it's really like, playing in traffic. And it was really difficult to nail this particular galaxy down. And it took decades to figure out what it was. That's a mistake, by the way. It's magnitude 10. It was discovered by then New York amateur astronomer Lewis Swift in 1887, 100 years after NGC 185 was discovered. And he started out as a Rochester, New York merchant, became an amateur astronomer, made all these discoveries, attracted the attention of a mentor who built him this observatory in Rochester with a 16-inch Alvin Clark refractor, which is like absolutely amazing. And he made 1,200 discoveries of nebulae, which is second only to William Herschel. And William Herschel was really like such a stud when it came to discovering stuff. He's just, it's a shame he's largely forgotten these days, but he was really quite the observer. And he discovered a bunch of comets. And one of these you may be familiar with. Anybody?
Landed showers.
Perseids? Favorite summer shower? Yeah. So, trying to figure out what this galaxy really was. In the 1930s, Edwin Hubble thought maybe it was extragalactic and maybe a member of the local group. But radial velocity studies in the 1960s pinned it down as approaching the Milky Way, 350 kilometers per second. And finally, Cepheid variables were discovered there in 1996, which kind of pinned it down as a member of the local group. So today we think it's an irregular satellite galaxy of M31 with extensive dust and gas, and the only starburst galaxy in the local group. And I read that this galaxy produces 0.04 stars per year. So I don't know what that means, but every 25 years, I guess, there's a star on average. Alan Purdy observed this with a 22-inch scope, and he said it's a 10.4, but very spread out and dim. And this is a drawing of it. And they're talking about a galactic merger. It kind of looks on this drawing that maybe there were 2 separate pieces. Don't know. Next one is a surprise, right? I never realized M33 was a satellite galaxy of M31, but it's listed as such. Most distant naked eye object, I guess. Magnitude 5.7. Third largest spiral galaxy in the local group of galaxies. I think it's about maybe 4% the size of the Andromeda galaxy and about 40% the size of the Milky Way galaxy. So kind of big, and it has its own satellite galaxy, which would be plotted right about here. I plotted it, but and that's called the Pisces dwarf. But the big thing about this galaxy is its spiral arms, but of course also all these little H2 objects. This is just a chart that's annotated with all these little H2 objects that are floating around in that galaxy. The photograph doesn't really show them to advantage. I think if there was a hydrogen alpha filter and some monochrome imaging, that would show it better. But this drawing is absolutely beautiful. It was done by Peter Kiss with a 16-inch f4 scope. Peter Kiss is a Hungarian physicist that is also an amateur astronomer and draws at the eyepiece. And his website is just fabulous. I would really recommend it to you if you ever get a chance to take a look at that. It is great. It's one of his drawings. And I checked that against the photograph, and it is so unbelievably accurate. It's crazy. But he has a whole website filled with them. The brightest of the rest, Andromeda 1, Andromeda 2, and Andromeda 3. And they were discovered by Sidney Vandenberg, who was a Dutch-Canadian astronomer who was looking over Palomar sky photographs taken with the 48-inch Ocean Schmidt camera, and discovered these in 1970. And I thought for the purposes of it, maybe try to photograph one of them. So I selected Andromeda 2, which is listed at magnitude 13.5. So maybe I'll give it a go. So this is the finder chart taken from Sky Atlas 2000. And here's the field. These little guys are like 15th magnitude and about 250 million light years away. And they kind of show up faintly with like 5 hours of exposure. Andromeda 2, no. So, and that is the brightest of the three. Andromeda 4 has been found not to be a member of the local group. And Andromeda 5 is like 15.5 magnitude. So I think probably the ones that we just mentioned are probably the ones that are visible in our amateur instruments. I don't know of any others, but unless someone else has some ideas. Anyway, the one takeaway I had from this was when I started to just annotate. Mike Atwells graciously gave me a new copy of the Pocket Atlas a couple of years ago, because mine was like falling apart. And for the purposes of this, I started annotating some additional objects on there. And of course, this is a map of the local group. This was put out by Astronomy Magazine about 20 years ago. And it shows two little neighborhoods, one with the Milky Way. There's Radnor. And one with the Andromeda neck of the woods right here. And it slowly dawned on me that just about everything on this side, in this part of the neighborhood, could be plotted on page 3 of the Pocket Atlas. And I thought that was kind of crazy, you know, and kind of makes it a special part of the sky, you know. Anyway, thank you so much for your time.
I have a question.
Yes.
A dumb question. What makes it satellite? Why is it so far apart? Why is it satellite?
Yeah, well, I guess it's I guess the definition is probably within like the gravitational influence of it, you know. I think that is probably a big part of it.
Gravitationally bound.
Right, yeah,
The
yeah.
definition.
Like that 185 and 147 that they're gravitationally bound because they're fairly close to one another. Yeah, I think that is probably one of the parameters anyway.
But how do they know they're gravitationally bound?
Well, I guess they figure out the mass and they figure out how close they are to one another, and I guess they infer that, you know. I mean, I don't think anybody.
Too far away to see any change in
Right.
you know, over a century even,
Yeah.
you know, but they have similar processional velocity. Is that why they don't belong to the same?
Well, I know with the case of 110, that was one of the parameters that they looked at in order to include that. But I would think that if they know the masses and they know the distances, they could probably infer the rest, wouldn't you think?
Yeah, you can measure radial velocity at least. I don't know if they can measure transverse velocity on these galaxies yet.
Right.
But if you assume the transverse velocity is similar to the radial velocity, you know the space velocity of the galaxy. And if it's less than the escape velocity at that distance, then it's gravitationally bound. That's my out-of-date understanding. Yeah. All right, I'm Jeremy Carlo, Programs Chair. First, I'll give you a little update about upcoming programs. So in December, we'll have Mike Siege, who's a professor at Franklin and Marshall College. He'll be talking about how the stars made dinosaurs and us. So it'll be about how the chemical elements were formed. A few hot off the press. In January, we're going to have Teddy Coretta, who's a professor at Villanova, actually just started in the last couple of months. So he does solar system astronomy. He'll be talking about small objects in the solar system and meteor showers. In February, we'll have Ekta Patel, who's also a new professor in the astronomy department at Villanova. So she'll be talking in February. And then in March, we'll have Professor Erin Crail from Kutztown University. So that's all we have so far. We'll have some getting a little feedback. Yeah, so that's some good programs coming up. This month, I'm proud to have Deborah Skapik. She is a teacher at Friends Central High School and also an adjunct professor at St. Joseph's University. She's been instrumental in getting high school students involved in astronomical research and several different projects, which have led to some really nice results. And most recently, she was invited to participate in a program called the Astronomy in Chile Educator Ambassador Program, ASAP or ACEAP. So she's here to tell us a little bit about that and a little bit about astronomy in the mid-21st century. Please join me in welcoming Deborah Skapik.
Thanks, everybody. Thanks, Jeremy. I think this is loud enough, right? Yeah. Okay, great. So I titled this talk something a little different, which is Cosmovision and Observational Astronomy in the mid-21st century. So there's sort of like two parts to this, but they are blended. And I want to kind of define for you this idea of cosmovision to begin with. And then also realizing as we move through 2025, we're actually moving toward the middle of the 21st century. It's hard to believe that, but it might dawn on you that that's actually where we're going. And just thinking about do I just click the arrow?
Yeah, or you can use the
Fancy thing. Okay, pointing at this.
down arrow.
Down arrow advances. Okay, that's a little counterintuitive. Okay. So I'll talk a little bit about my background on what ACEAP is. Also, then we'll move on from there to looking at cosmovision, what is that, and this idea of supporting diverse ways of knowing. Then we're going to look back at astronomy as it has been in the past, astronomers in silos, figuratively, kind of almost literally, if you look at the shape of the things, and then looking forward to connections and partnerships, which is where I think astronomy is moving right now. So who am I? As Jeremy said, I'm a St. Joe's adjunct professor. I also teach high school. I've been at the Friends Central School for now almost going on 25 years there. And I teach physics and astronomy. I'm also a class dean, so I work with high school students all day long and then zip up to the college at night. But I have been doing a lot of outreach. I started my career in astronomy doing running the Flower and Cook Observatory for University of Pennsylvania. If any of you are familiar with that, that was out in Malvern. And then a couple of years ago, my students actually presented here. Some of you may remember that right as we entered the pandemic, we were talking about pulsars. We had gone to the American Astronautical Society meeting in Hawaii, and we had done some pulsar research, so we were talking about that. But I also do a lot of outreach with eclipses, and my own area of research has nothing to do with any of that. So I was looking at distant galaxies and something called the Butcher-Ulmer effect, which has to do with the bluing of galaxies at higher and higher redshifts. But I do other things like have kids and stuff too. So, right, that's me. ACEAP is a program that was started almost 10 years ago now, and it's a really cool program. I would encourage everybody here to apply for the program. It was amazing. It chooses about 10 international educators, planetarium directors, personnel, and just people who are enthusiastic about astronomy to get together and visit the Chilean observatories in a 10-day whirlwind trip, and also the operational support facilities. So that includes Santiago, that includes the areas that are not necessarily at altitude, and you get to see what people are doing and how these observatories are run. It's a huge collaboration of a whole bunch of places that have acronyms that are varied internationally. So AUI, the Associated Universities, AURA, which is the research and astronomy thing. It's kind of a combination of the old NOAO and RAO group. NORLAB is also part of that with infrared included, and ALMA, which is the Atacama Large Millimeter Array. All right, so one of the things that we were steeped in this entire time that I want to introduce you to is this idea of cosmovision. And that includes thinking about all four of the things, I can't count, all five of the things listed here, the earth, the universe, you in the middle, and the past and the present. So it's time-wise and space-wise, thinking about how it is that we are all connected, how you are connected to this planet Earth, and how that connects to the sky above us. So we spent a lot of time thinking about the cultural dimension of astronomy in and around looking at all the technical pieces and parts that I will share with you coming up. So sort of just the preview is where we're going is we are going to be walking around in the Rubin Observatory building within a week of it seeing first light. So we are going there, but before I get there, just thinking about how Chile is situated for specifically for astronomy, and then also what's going on with the local communities there, and how this partnership, and it's a true partnership, was really worked out very well for both groups. So you can think of other places in the world where maybe this isn't working out so well. For example, if I just say TMT in here, probably a lot of people will understand what's going on with that and how that's not working out so well. But in Chile, astronomers recognize that the Chilean Andes, specifically the Atacama High Desert, is ideal, unparalleled conditions for astronomers. World-class astronomy because of the dryness there, about the way the winds blow, about being near the sea, but up high enough so that at night things clear out and it is ultra, ultra low humidity. I keep telling this story about how when we did go to Alma, the humidity reading in my room where it was supposed to be, there was a humidifier on, it was only 18%. And so within a day of getting up there, all of us were cracked, dry, and bleeding and seeking hand cream wherever we could go. But it's wonderful for astronomy, and the high altitude puts you up with low light pollution so you can see everything. And I will show you some pictures that you will be drooling over because you will see stars down to the horizon. It's incredible. So that's ideal there for optical and ground-based, not only optical astronomy, but IR and some submillimeter. So the astronomers liked the idea of going to Chile and didn't just go into the local communities and say, we're putting a telescope here. They said, we would like to do this. This is lovely. How can we work with you to preserve your culture and heritage? So there are deep connections for the Chileans who are indigenous to the land that are working with the earth and respecting the earth and also connecting to the sky. And looking back to their ancestry and how their ancestral stories tie into the land and into the things that they do see in the sky. We had a few guides at different places, and one of them told us that actually some of the things that we read in our history books are incorrect, and that the Incas that inhabited that area longer ago than, for example, is recorded. So they see their past not in connecting stories by connecting dots in the sky like we do to make constellations, but in the dark patches in the Milky Way. That's how bright the Milky Way is there. We went to two places to learn about this. One was called Alpha Aldea, and Alpha Aldea was outside of La Serena. We flew from Santiago to La Serena and drove inland to Alpha Aldea. And where we were, is there a pointer on this or no?
Yeah.
Excellent. All right. So when we got there, we unloaded out of our little bus and we saw this mountain in the distance, which from this photo where you're sitting, you cannot see it, but we were all shouting and jumping up and down and hugging each other and with tears in our eyes because what we could see on this ridge, this is Cerro Pachón, and on Cerro Pachón is Gemini South and the SOAR telescope and the Rubin Observatory. And that was our first glimpse of it in the distance there. We didn't quite know what we were in for, but we spent this wonderful evening learning about inclusive astronomy and how Alpha Aldea, the folks who live there, is a family-run business. They were bringing in the local communities, educating them there, and in this beautiful privileged dark sky spot, and they want to invite people to participate in astrotourism. So they're really looking for more folks, not just local folks that are there, to come and enjoy and see this beautiful sky that they have. On the other hand, at sort of after we'd gone and done our technical trip, we went to Reserva Elemental Purbeter, and here we did a number of things. Here we were in the Atacama High Desert, so it doesn't look like it. Here we were in a valley, clearly. Here we were actually at altitude. In the distance, you can see snow-capped mountains, but we were at 8,000 feet here. And this was a photo that was just taken, I think, with my cell phone. And you can see the Milky Way here and this, you know, sort of sunset light in the distance. And I had a campfire behind me. But we talked there about taking care of this treasure that we have, which is the earth, and how that is connected, again, to past, to present, to the sky. Our guide there was named Carmelo, and he told us a story that I think really illustrates well this idea of all of these connections and this concept of cosmovision. And that's the legend of the Dark Llama. So if sound is working out, what should happen is a song will start playing. So do I have to do something to make that occur?
Click something in here. Do you have to click something on here to play it?
Oh, maybe it's over there. I see it. That thing. Oop, on the, oop. Wait a minute. No. I try to make it too fancy, maybe. Nope. Okay, it was that maybe. Oops. Yeah. Okay, great. Okay, thank you. All right, so I want to tell you the legend of the Dark Llama. So according to Carmelo, there once was a dark llama. Most of the llamas were light in color, but this dark llama would take a walk every day from those mountains that you saw in the distance all the way to the sea, and it would take a drink from the sea, and then it would walk all the way back to the mountains. It would do this once a day, and when it was walking back to the mountains, it would drop the water as blessings along the way in the form of dew or in the form of rain to water the land so that things would grow. Because remember, I said this is the high desert, so appreciation of the water coming from the sea to water the land so they could have food. Well, there were some hunters that got really excited when they saw this dark llama and they started to chase it. They wanted to catch it. Llama figured out what was going on, ran to the edge of a cliff. When it got to the edge of the cliff, it jumped up into the sky. But knowing that it still had to bless the land each day, that llama, which was now in the Sky River, the Milky Way, would then rise once a day from the mountains and then dip over into the sea and then come back up on the other side. What you're hearing is the song that Carmelo was playing. I was taping this on my phone around this bonfire. There he is in his ceremonial robes, playing the pipe and the drum at the same time. So this was really special because we were out under this beautiful night sky, seeing the Milky Way. This photo is actually one I took at Saratololo. I have a print of it over there so you can get a closer look. But what star is this? Antares. That's Antares. We got Alpha and Beta Centauri over here, but I see the dark llama in here. But it's just amazing to be under that beautiful dark sky and have that appreciation of what was seen by people in the past, what will be seen by people in the future, and what is seen now in the present with no light pollution, because the Chileans appreciate that. Okay, and preserve their sky. So we can stop that. All right, thank you. Just wanted you to hear how beautiful that was. Little of that experience. Okay, so this idea that I've been talking about is this idea of cosmovision, which is defined by Yasmin, who was our guide, and some others, Yasmin Catriccio, an individual or culture's way of knowing and being emanating from the holistic, natural, cosmic processes that has led to the present state of the universe and what is yet to come. So we can talk about living in a galaxy called the Milky Way and understand that when we see that rise and set scientifically where that's coming from, but also incorporate this appreciation that there are other understandings of it, and it's really beautiful to get to know that around the world. All right, so while we were thinking about these things, you know, I have these kind of two pictures side by side, unless otherwise indicated, the pictures and stuff in here are things that I took. But the one on the right is, this is the Blanco Dome on Cerro Tololo. It does need a power wash. But you can see above it, the Milky Way. This is probably a 5-minute exposure guided. And if you want stories about taking equipment on airlines from here to South America, I could tell you it's not that easy with tripods especially, but something flew through here. But anyway, I was tracking over here, this picture I took at Alpha Aldea. And to me, this picture is really special because this was just with my cell phone and I was walking and I looked over my shoulder because we were told we were walking from the lighted area where we had been eating this beautiful meal to another area that was darker. And on the way, I looked over and said, oh my gosh, Magellanic Clouds. And I had to get a picture really quickly. So you can see there's, you know, vignetting, this thing hasn't been processed or whatever. And yet there they are. But look, this is what I'm talking about. Down by the horizon, can you see all these stars? So I printed that as well. So that picture is sitting over there and you can take a closer look. But I even got a meteor in there, right up there. But, you know, you can see this coal sack right up in there. Just really incredible sky. So the sky is for everyone, whether you're appreciating the beauty of it or whether you're doing some technical work inside of a dome. So speaking of technical work inside of domes, astronomy in the past, I was really grateful to see the prior presentation, you know, talking about Herschel, talking about other astronomers. When we think about observational astronomy in the past, we think about probably individuals behind telescopes, maybe either just looking through in a dome by themselves, you know, shivering behind an eyepiece somewhere on their own, or maybe in a cozy control room. But, you know, I listed from the 20th century anyway, some of the major ground-based observatories and things that include more than one telescope. So, you know, of course, it's not a comprehensive list, but some of the major places in the world that were doing astronomy. So Kitt Peak in Arizona, of course, there's Whipple and Griffith and Lowell in that area too. Mauna Kea, you've got, and also Haleakala, these mountains that have many multiple domes on them. The Canary Islands, right? You have others, of course, I didn't list Palomar here, but that's included, and CTIO, right? Which has a twin on it of the one that's at Kitt Peak. And RAO, these big radio observatory places like Green Bank, the VLA, Arecibo, the Parkes Observatory in Australia. So these big astronomical centers, which were really only accessed in the 20th century by professional astronomers who had to propose, kind of fighting over the 365 nights per year that were apportioned out, but, you know, others weren't really having access to these. Telescopes, then if you're picturing them like that, they sort of are like this, and some of these are still around. So this is me at the 36-inch telescope, which is interesting to me. This is on Cerro Tololo, but this is from Bowler and Shivens. And, you know, there are still places up there that have eyepieces in them. So they're not all detectors, but this is, you know, kind of a neat piece of equipment, which reminds me of the Flower and Cook telescope that used to exist there. And kind of fun to see this little finder scope on the side of it. But, you know, I think, again, that's what people picture as individuals looking through, probably. But that is not where we're headed. I mean, if it's fun for us, you know, doing amateur astronomy, looking through that way, but observational astronomy, as we move forward, is changing. And this is the new flagship, which literally kind of looks like a cruise liner. That's the Rubin Observatory. The telescope itself is up here. This is where all of the offices and control rooms and things are. I'll show you some of those. It is not a car dealership, but it looks like that. All right, so this shift is moving to remote observing. And that kind of got started, you know, by necessity. Space telescopes have to be operated remotely. I mean, there's no other way. So that move to HST, you know, the James Webb, they're getting our deepest images, the Vera Rubin telescope. These are discovery instruments, and then follow-up has to be done by others. So the successful telescopes, the big ones for research, are not being decommissioned now, but they're being recommissioned. So I'll show you something called the SMARTS telescope, which is next to the Blanco telescope at CTIO. And that one is operated by a bunch of collaboration of universities, but they're changing over, okay? So you might have heard, I'm sure you heard, that from the first light images of the Rubin telescope, like 2,000 asteroids were discovered almost immediately. That's like a frightening number to know. My team at Friends Central has been working to find asteroids, and in, you know, the 8 years or so we've been detecting, we've only found about 200. So this is an incredible shift. While we were up there, that was announced this summer, and that's a sort of an older image, but you know, everybody all of a sudden turned their telescopes to go chase that thing, whatever it is, TBD, not aliens probably, right? Okay, so why are we turning to remote observing? The prime observing sites are far away from things by necessity. So far from civilization, generally inhospitable. This is a view of the Rubin Dome from another angle. That's its supporting observatory next to it, its little friend. And we were back at Gemini South taking that shot or that look, but there is nothing around here at all. And I showed you the view from Alpha Aldea looking up, and the surrounding community in Alpha Aldea is kind of rural as well. We were there touring for 10 days, and this, I think it's the next slide, is going to give you some idea of what it's like as we move around. Oops, it's just not advancing now. Wait, oh, I'm doing something dumb. Okay, sorry, I was hitting the laser thing. Okay, so hopefully this will, oh no, yes, there it goes. Okay, this should not have sound, I'm thinking. Let's just make sure it plays.
I think it has to open the link.
Oh, okay, I see. So what I did when we were on Surapachone, just to give you a taste of what it was like to do this touring, was I wore a silly hat that I actually made. My son made it actually, and he glued a GoPro camera to my baseball cap. So what you're gonna see, do I have to click it? Yeah, I can just talk while it's doing it. Oh wait, let's turn the sound off. Turn it all the way off, it's just music. Thanks. Yeah, okay. Quite enough, I guess, just funky music as we're running around. But anyway, just sped it up a little bit so you could get a sense of what it was like for the ambassadors if you choose to do this, or how exciting it was for us to get out of the van, back into the van, get out of the van, get back into the van. We got out and then kind of walked around and looked. So the 10 people that you're seeing here are all from all over the world. So there are people who are from Spain, there are people who are from France, there are people who are from Arizona. You know, it was kind of really exciting to sort of be, I felt, with my people, you know, we could geek out about astronomy and talk and say, you know, things like I see and M, and people knew what we were talking about. Daniela is there from, yeah, she's from Italy, actually. So I guess I took my hat off, but what you're seeing is, then we go into the telescope domes. You can see up there, it is cold, cold, cold. In this middle of July, there's Amy Oliver from Whipple Observatory playing with Snowball. solar panels for their power, because of course you're not going to run power lines to these remote observatories. So just imagine all the infrastructure that has to be put up to be able to have these telescopes operating. When we went inside, we would have to take off the hats that we had on and stuff and put on hard hats. You'll see some of those, and safety vests in every single dome that we went in. We had to have the protection. You'll see other people wearing those as well when I show you some photos from inside. But just the views were spectacular, and we couldn't resist getting lots and lots of pictures of domes, but also of the surrounding sky. And I assure you, those clouds did settle at night. So you see some clouds there right now. That's from the SOAR telescope, looking back toward the Rubin Observatory, looking back toward Gemini South. Going into the SOAR telescope, I have some stats on when it was built and how big it is and everything coming up as well. But you can see the flags that are hanging in there. One of the highlights of the trip was learning about the international kind of collaborative things that are going on. Laura May Abron, who is right in front of me, right here with the blonde hair. It was ironic as I was coming in here tonight, she was texting our group saying, "Hey folks, are you giving any talks about ASAP?" And I'm like, well, as a matter of fact, tonight, walking in, but she's the astronomer in residence right now at Kitt Peak. So unloading van once more, this was our first walk into the Rubin telescope. Going inside, and again, we were there within a week of it seeing first light. So we were the first group from outsiders to tour. So that was really special, it felt. As you go in, you see that there's actually a stone there, the cornerstone thing, and it's labeled LSST. So some of you will remember when it was first conceived before it was named the Vera Rubin telescope, this was the name of the telescope because of the survey work that it's doing. And it's an incredible instrument that surveys the whole southern sky about twice a week. It's incredible. The paint was still drying. I mean, you could smell fresh paint as we were walking up the hallway. That's Vera Rubin blue. Moving in as everyone else is going in to the rooms, I got lost, which is cool because then you can sort of see around what's going on. And they have this big conference room and educational space. The way that Vera Rubin was conceived, the telescope, the idea of this, that did not come out right. From the moment that the ideas were born about the telescope, education was key. So they launched their educational rollout at the same time that they launched their science rollout. So those of you who are educators or who are interested in this stuff, Vera Rubin telescope website, observatory website, has fantastic educational materials, activities for students to do, activities you can do, and the data that's coming from that is crowdsourced through a site called Zooniverse. So anyone can participate in citizen science from the data from this telescope. All right, that's probably back to the thing, making Jeremy work here to go back and forth between these things.
I think you're on now.
Okay, so no.
Where exactly is that Vera Rubin located?
On Cerro Pachon, so this is, you fly into, I don't think you can fly directly to La Serena, but you fly to Santiago, Chile, and then fly to La Serena and then drive up. Okay, great. So in this observatory, it is, again, it's a big collaboration, NORLab, which is same thing sort of as Aura, and SLAC, which is the United Kingdom, and France are affiliate partners with it. Oh, you know what didn't happen? There should have been a YouTube embedded in that top right corner. Shoot, well, I guess that's okay, but I'll explain what that is. Because that's kind of cool. But it's funded by the NSF and the Department of Energy Office of Science. You asked where it's located. It is about 8,000 feet up on Cerro Pachon. And again, the purpose is this LSST, the Large Legacy Survey of Space and Time. Okay, for 10 years, it slews really fast. So the qualities of it are incredible. And this video, I'm sorry, is not up there, but it's an 8.4 meter diameter mirror. I will show you some photos of it. And it's unique because it's 3 mirrors in one, and it's short and stumpy. Because the light comes in, it hits the primary mirror, bounces up to the secondary, and then back down into the center of the primary, and then back up into the camera. So I will show you the pictures again, because you can't see it. It's so cool, but it squishes the whole design. So it's not a long tube, like you would expect a reflector to look like. So it looks kind of short and squat. Because it's so compact, it can slew so fast. It's like whipping through the sky. Again, it surveys the entire southern sky in 3 to 4 nights. I can't emphasize enough how incredible that is. So you can see things varying in brightness. You can see, moving targets. All of that is being discovered by the Rubin telescope and is producing incredible amounts of data for people to comb through. But
Is the camera embedded in the second mirror?
The camera is above the second mirror, is kind of embedded in it, but it's about the size of a minivan. So it's not really embedded in it, it's like looking through it, but yes. The field of view is huge, 3.5 degrees on a side, you'd fit 40 full moons in there. And the resolution, I'll show you some pictures of how they're trying to achieve higher and higher resolution. It's seeing limited. They have active optics there, not adaptive optics. So it's not like Gemini where they shine a beam into the sky onto the isoplanetic patch and watch for that to change. They're actually just adjusting pieces of the mirror based on the weight when it shifts positions. Okay. So 0.2 arc seconds per pixel. Mirrorless. Oh gosh, there it is. Okay, great. So now, do I have to hit something?
Probably have to click on it with the mouse.
Okay. Where's the mouse? Clicking.
Probably have to move to the right onto the slideshow.
Oh,
There it is.
something happened. Okay. Oh, well, great. So it's going to show you. Oh, here, maybe I can make that bigger. I can't see it. I can't do it. So it's probably not big enough. All right. So here we go. Combining two different mirrors. The Rubin's, that's the primary with the kind of scoop out of the middle of it. And you can see the light comes in, bounces up, bounces back down, and then back into, see how the camera is up there. There's the hole. Okay, that's what I want to show you. Yay. All right. And now, what do I do? Go back here.
Oh, you got it. All right.
Did I? Okay, I'm learning. Okay, and just making it harder on you here. This is another video. It should play at the same time, though. I don't know why it's doing that. Do I have to click again? I don't know what happened. Okay. So in the control room of an observatory, you might expect 1 or 2 screens. There are, I don't even know how many screens. And this is daytime. And that's what's going on in the control room. So what are they doing in there? They're trying to point around at different physical positions so that they can see how the mirror distorts itself and they can make active corrections while it's doing its work at night. But there's a humongous staff that's employed by this observatory, educators, operators, all that stuff. And stuck to the window here are on paper. It's so funny because everything there is so sophisticated. And then they have these pieces of paper taped up. Guesses as to what that is?
Schedule.
Nope. Yeah, it's what dates they got the highest resolution images that they possibly could. So it's like a little contest, or they're excited, what's the best that they can do. All right, so again, seeing limited, so how well can they do? All right, here it is, the Vera Rubin telescope on the right, up toward the front. That is looking at the camera end of it. It just really made my life difficult with this. Let's see. Maybe that will play if I click it again. Because, oh, this is it slewing. I can't even remember. If I click again, will it work? Why do I just not?
You have to go to the
Go to
video,
it,
click on it.
Yeah, I don't know how to go.
Move to the right,
Center.
Yeah, there's no triangle on this screen.
move the mouse to the right, and it'll go to that screen.
I think if I,
Move it all the way to the right, and then it comes up on this screen.
oh my gosh, okay. It's a split, I don't know. Okay, well, you're hearing it, but that's slewing. And so the whole telescope, like I said, is sort of short and squashed together. And it's weird to see a telescope like this because Usually at the back end of a reflector like this, you're gonna see all the instrumentation and the eyepieces of the cameras or whatever, but you don't, you just see this flat part coming up. And again, it's an 8.4 meter diameter mirror, so it's huge. It's an amazing, amazing engineering feat. Back here. Bring it over and play. All right, so we were there again within a week first light. On the right, you might be able to spy what I did. I stuck an Eagles magnet on the rear telescope. I did.
It's a foul.
Yeah.
So it's a magnet, they can move it. Right, so also up there on the ridge is Gemini South, you know, not to be outdone by the telescope. So what do? You put another 8 meter telescope up there. What are these doing? These are now doing the supporting work, following up the discoveries from the Rubin telescope. That's what all the other telescopes are going to be doing now. Gemini South saw first light in 2000. Again, it's on Cerro Pachón, and it is a collaboration of NORLAB and lots of international partners. So once again, international, big collaborations, everybody's taking part. It's not people in silos alone. Another 8-meter telescope, optical and infrared, and it's coated in silver, okay, which is amazing. So we saw the mirror coating lab that's there on site as well. It does imaging and spectroscopy, and it has adaptive optics. So this right-hand side, I think I learned how to do this now. Move over and wait, no, I have to click it first. Click it, and then I move over to this side, and I click there. Okay, I'm doing this because I want you to see the reflection, because it looks like water, but it's actually silver on that mirror, not aluminum, so they have to coat it very frequently. But it's sensitive to infrared radiation as well as optical. Oh, no. Okay. Right.
How often do they have to recode it?
I don't remember what they said in terms of frequency, but it's often enough that they, you know, actually have to rely on other telescopes for work up there. But the SOAR telescope gets recoded there as well. There was a poster that I have taken a picture of here. So the coding process it takes 7 hours, but I don't know how often it is. But it's like silver, it's gonna tarnish. So any silver jewelry you have. But you can see in the paragraph above on the left, it was the first large telescope fully coated with protective silver, and that happened in 2004. But I will check on that because I'm not really sure how long or how often they do. Anyway, I was just kind of fascinated with the work that has to go into doing all of that stuff. Okay.
Do you happen to know what the first light was of your Rubin?
Well,
What object?
it was they put the images online, but there are a couple. They had a galaxy cluster. They had nebula, the Trifid, maybe, and yeah.
Wasn't it that giant field with all the galaxies?
Yeah, there was this bunch of galaxies, but also there was the Trifid nebula, I think.
Yeah, I think it was.
I want to say it was the Trifid. Okay. Maybe a video, but I'll skip it. If it is, I think it might just be pictures. So this is the SOAR telescope, which is also on Cerro Pachón's Ridge, stands for Southern Astrophysical Research Telescope, 4-meter primary mirror. It also does IR work, and it had its first light in 2006. It is operated by the NORLAB, but it's international and has partners also in the US. There's our whole group there underneath it, so it gives you a sense of the size and scale of this telescope. This one is more traditional in that it has the detector on, you know, where you would expect it to be, and you can see the adaptive optics wires and stuff there. Okay. We came down from Serapachona, and the very same day we went right back up the next mountain, which was Saratololo. So CTIO is where the first telescopes were put in Chile, and the largest dome there is the 4-meter Blanco telescope, which is the twin of the Mayol at Kitt Peak. Where I'm taking this picture from, obviously this is daylight. I'm down at the kind of residence level, so we stayed nearly at the summit, but not on. And then I'm also looking up over at this other additional ridge. If you ask somebody at Saratololo how many telescopes there are up there, they'll say about 40. That's an interesting answer, right? Because like, can't you actually count how many there are? But that's approximate. There are so many domes up there. It's phenomenal to see. The oldest one up there, I was told, was from 1967, but when I took a picture, you saw 1965. So I don't know if that's when it was built and then brought down, maybe saw first light in 1967, but it's a 1-meter telescope, 0.9-meter telescope that's operated by Smarts, and it was moved from Kitt Peak to this observatory. This is just a couple of pictures of the kind of variety of things that you get there. Up here in the upper left, for those who appreciate solar astronomy, that was when I walked in tonight. I saw you talking about that. That's the Gong telescope. Looks like a shipping container, but it's a spectrohelioscope, I guess. And there are lots of telescopes kind of on the lower ridge. They call that area the mushroom farm. So it looks like that. I was very excited to see the Las Cumbres Observatory telescopes there. There are 3 of them that I was standing next to, and there are 3 others hidden in the mushroom farm somewhere else. But I had actually remotely just used one of these. And so on the 27th of June, my observations of a field where I was looking for a particular asteroid were taken. And so it was exciting to be right there at that dome. Some of the telescopes don't even look like telescopes. They look like just a camera, maybe. You know, this one, for example, is the this project that's a collaboration of a number of groups. The Las Cumbres observatories that I just mentioned are completely remote. This is a daytime photo of the 3 domes, and then a nighttime photo. These little robotic telescopes open themselves, and they operate on a queuing system. So I'm a member of Global Sky Partners. People who can send in their observations, they get put in a queue, and then the observations get done when the telescopes have time to do them. So I think this is a really wonderful opportunity for educators, for people who want to use remote telescopes. My next remote telescope observing time, not on these telescopes, but on the Falks Telescope North, which is on Haleakala. It's a 2-meter telescope. I have a half hour of 2-meter time, Tuesday morning, November 11th, from 10 to 10:30. So it's really fun to observe remotely on these telescopes, and you know, have a half hour of time every now and then. So that collaboration is called the Schools Observatory. But I just love the idea of watching little domes open and operate themselves. The second evening we were up at Saratololo, we set up shop, and a lot of us did different things. So what was really beautiful about this night is tying back to this idea of cosmovision. All of us were just having a blast, having fun up there. And so I set up a tripod with a camera on it and the tracker, and I was making art. I was not really interested in science that night. I just wanted to make something beautiful. And so we had a moon, which is causing all the light on these domes. This is the Smarts dome. This is the Blanco dome. And I took several images of the Milky Way and co-added them and got this, beautiful sky. This is the sun is setting over here. So there's still some light, but it goes from being light to being pure dark. It's beautiful. Other people that I was with there, as I was doing this kind of stuff, were taking some serious images, but some were, I couldn't believe some person up there this is Laura May, lovely, just opened up a bag, pulled out a canvas, plopped herself down on the ground, put on a red headlamp and started painting. She just brought oil paint and started painting a picture. Another member of our group, Amy Oliver, took out a red flashlight and started having people draw shapes in front of her camera, in front of the domes. And actually one of those photos, I was glad you mentioned Sky and Telescope, will appear in the January issue, if you have it already, of Sky and Telescope. In the focal point, there's an article about ASAP. We're in there, and Amy's picture of Bill drawing a red heart in front of Blanco is there because he was very connected. He felt to the Blanco telescope since he's Puerto Rican, and that telescope is too. So he was, showing his love for that. I guess that was Bill painting the heart. Sorry, that was Jose who was.
What was the
connecting to it.
moon's phase at that time?
It was pretty close to full. It was really bright. Yeah.
it Still looked that.
Yeah, it still was amazing. Yep. All right, so the point of all of that is, observational astronomy in all wavelengths is changing. So radio astronomy is turning to these, long baseline arrays, not single dish things anymore, and the multi-nation collaboration. I can't emphasize that enough, that we have all of these countries working together to do better astronomy, big collaborations. Infrared astronomy, you've got this James Webb Space Telescope observing the infrared that's totally changing the landscape for infrared astronomers, but we still have to do follow-up observations after things are discovered from the ground at these high and dry sites. Optical astronomy, the smaller ground-based telescopes are now in supporting roles. Okay, they still have good work that they can do, but they have to follow up these discovery instruments, and they are being run remotely. And it's getting really good, right? It's getting very easy to do that to the point where, anybody can just go online now, kind of reserve time on a remote telescope. It's pretty cool. And ultraviolet might be the new frontier, but all that has to be space-based. We did visit ALMA, okay, and this is, again, this is about 10,000 feet, so we're already a little punchy when we're up there, but ALMA stands for Atacama Large Millimeter Array. So to get there, we had to come down from Cerro Tololo, fly to Calama, and drive from Calama all the way up to this facility. ALMA has 22 countries partnering in it, 22 countries. What else happens on this earth that peacefully has 22 countries running it? I can't think of anything except something like this. There are 66 telescopes up there. 54 of them are 12-meter dishes. 12 of them are 7 meters. They each cost about $10 million. They are located at 16,000, almost, 16,000 and a half feet up. To get them there is not an easy journey at all. The roads are narrow, they're dusty, they're dirty, they're rocky. They had to be built for the array. All of the infrastructure had to be made for this. To build this, there was a lot of cooperation between the local Chileans and the government. There was so much respect given to even plant life that was growing up there because it's a desert. There's very little water. So cacti that grow there don't grow very large. And so if roads needed to go through a certain area, those cacti were respected and moved out of the way and not just done away with. It operates all day and all night. They have high resolution, about 0.5 milli-arc-second, and they're getting a huge upgrade. If you want to read about the upgrade, there is a wonderful article on ALMA that was from this summer's Sky and Telescope, maybe the August issue. That's really cool. To get to the summit is not easy on the human body. We had to have tests. They told us, they warned us, if you want to go to the summit, don't drink any coffee. Don't drink any alcohol for like a week before going. All right. So for someone who drinks like a gallon of coffee a day, I was really hurting by the time, but I passed the medical test to go up there. Of the 10 of us, 3 people did not make it. And I was older than some people that didn't pass. So I was a little, I thought that was weird. But anyway, so going up, you can see there we are. You have to wear oxygen, even in the car. And our driver, Maria Fernanda, has been up there often. So she has like the nose thing. But on the way up to the summit, you see wildlife, which is incredible, above the 10,000 foot mark. So we saw vicuñas, which are sort of like llamas, but not exactly. And also kind of low down on the road in the snow, there was something called a vizcacha, which looks like a squirrel kind of combined with a rabbit. I don't know. A vizcacha. This is ALMA. So again, these are all my photos. We were up there at sunset. And I have a million photos of the Alma antennas. So beautiful. You can see in the distance here, this is the Earth's shadow. Back, right, as the sun is setting behind me, but piles and piles of snow and these antennas moving around. How do these antennas get there? How do they get moved? By two huge transporters. Okay, so this is me below the antenna for scale. This is the tires. This thing has 28 tires. The names of the transporters are Lori and Otto. They've named them. All right, so again, on the left, we have the Blanco telescope, that where the astronomers are, and a group of ASAP folks having a good time in front of it, okay? And on the right, the picture I showed you earlier of Alpha Aldea, and just with a cell phone and naked eye viewing. The sky is for everyone, for the astronomers who go up to these domes and do research, to people just walking around in the desert and having this appreciation down to the horizon of the beautiful stars. I want to dedicate this talk to Almito, who is the dog that lived at the Alma entrance, who passed at the end of September. He apparently just wandered in one day and they kind of adopted him. So thank you very much. And
Well, do you have any questions?
yes.
When at the 8,000, 9,000.
Oh, I think he wants to talk about.
Sure you won't make it to this. At the 8,000-9,000 feet height observatories, do you have any issues with, altitude, getting used to that? I know 16 obviously.
Yeah. Yeah, so the 8,000 or 9,000 feet, you can feel it, and we stayed up there. The residence is up there. So, Cerro Tololo, when we went to Cerro Pachon, you can definitely feel it. So walking up the stairs, moving around, yeah, it's a little harder to breathe, and it's very dry. Sleeping there, it's a little funny. And there was one person in our group who didn't feel so well, but it's tolerable there. Coming down after being up there, it's suddenly like, it feels great. So like, oh, I can breathe again. But that was okay. The Alma residence is a little higher up than the summit of Cerro Tololo, where the telescopes are. It's weird to think about that, but when you're sleeping at Cerro Tololo, you're almost at the level of the telescopes. When you go to Alma, you sleep a little higher than where you were at the summit where the telescopes are at Cerro Tololo, but then you go to 16,000 feet, which is extraordinarily weird. And they, like I said, they have to check your blood pressure, your blood oxygen levels. We were only permitted to stay up there an hour and a half before coming back down. You can't remain there for.
So they didn't have to give you any medications for altitude sickness or anything.
No, but we had a few issues in our group. People who went up some people went up a second day. I said, I've seen it. I loved it. I don't want to feel gross again. I think I'll stay in the daytime down. I appreciated what I saw and I didn't want to push it. But there were two people that had not gone the prior night, so that they went up the next day. But two of the people that went up both times, when they came down, they had kind of big issues. So, yeah.
I'm curious, the Vera Rubin telescope is gathering huge amounts of data every night. And it's observing the entire southern sky every 3.5 days, roughly.
Yes.
So I'm curious about what the hierarchies are for how the data is interpreted.
Yes.
Some of it's going to be archived for future references, but for the immediate concerns, are there immediate concerns, priorities for observations, who's doing it, how is it being done, how's all that information being displayed?
Great question. I took some notes, and I of course left my notebook somewhere else, but I had written down, there were two locations that the data is pipelined to, so it doesn't get lost or destroyed. One is in France, I believe, and one, I want to say it's California. I might be wrong about that. But there's one site in the US and one site in France that is getting the data, and I'm not sure exactly how it's being stored, but I remember hearing the word terabytes, and that it is a tremendous amount of data. Who is processing it? There are pipelines for it. Some of that is AI that's doing that work, right? So there's a lot of support, supporting people that are writing code, that are combing through it. I'm not sure exactly what the processing chain is, but the Vera Rubin Observatory has a great website, and they talk about a lot of that stuff. So I would recommend looking at that to see what the follow through is. I know from looking at the projects that they have there that they put up things and said, right now we have sort of placeholder data for, I don't know, making an HR diagram or something like that. But that what our hope is that we'll actually have real star cluster data that you can use to do the work in these exercises. And so I think, you know, along the way, probably I would imagine within the next year, they're going to be taking that stuff and putting it in there. But I'm not exactly sure who is doing that. If it's people in the Santiago area, you know, or if it's people in the US or another country that are going to be doing specific roles. But there are a lot of people that are employed by the facility.
We couldn't ask the question.
Just thought of it. What's the situation with this AES green energy project? They
Oh,
couldn't
yeah.
carol
I know.
the observatories there.
Yeah, they're hoping that doesn't happen because obviously the light pollution, if you've heard about this, they're trying to build this large facility, and I don't know. I mean, I think that the people who understand and appreciate the dark sky are trying to work with that group to say, yes, we understand you want to build this facility, but realize that this is going to create a huge problem for something that's already going on. So it's discussion right now.
It would also produce dust and maybe affect the scene as well.
Yeah, so they're fighting it, but I think it's more like how they approach everything. It's sort of like, how can we all get on the same page about this so that everybody wins somehow? So I don't know. That's their approach. It was kind of like when they wanted to put the telescopes there in the first place. They said, we would like to do this. This seems like the good site for it, but how can we work, you know, to lease the land and make a minimal impact here? And what can we do as astronomers to make this good for the community around as well? So I don't know what the outcome's going to be, but the astronomers are concerned.
Anybody else?
Thank you very much. It was a really good presentation.
And I would say, I'll just flip through this, that if you go, and I highly recommend you do, go to see these observatories or just go to South America, that if you go to San Pedro de Atacama, which is out of Calama, quite close to Alma, there are other things to see, like flamingos in the high desert, which is wild to see, and it's beautiful. And there's, oh, come on, next slide, a meteorite museum. Extra, right? So just thought I'd pitch that one too. Thanks.
Thank you. Okay, well, that brings us to the end. So thanks everybody for coming, and have a safe drive home.
You did a good job.
Thanks.
Yeah.